Alright, today we're going to do lesson 12.3, exponential functions. Today we're going to talk about how to graph and evaluate exponential functions, and we're going to work on a little bit of vocabulary from kind of previous days and kind of refresh. We've already talked about exponential functions, but the only thing you guys did with them was you just kind of looked and kind of graphed them the first semester. So we're going to talk about kind of exactly what they look like, what you need to like kind of look for when you're finding them on your piece of paper and all that stuff. So the first thing is an exponential function is an equation in the form of, we're going to just do something general here. We're going to do y equals a to the x power. Alright, so that a can be anything. There can be some more stuff up with x. There can be some more stuff behind the a to the x, so you could have a minus or a plus sign after there. You could have something in front of the a. You could have a 4 or a fraction or a decimal or things like that. But this is the general idea. So the general idea is you have this y or f of x equals and then a number to the x power. And when you look at this equation, you have to notice that the variable x in this equation is actually the exponent. So the variable x is actually the exponent in this problem. So then all of a sudden, it's going to start doing some kind of weird things to the problem. All right. So for an example, y is equal to 2 to the x power. F of x is equal to 3 times 1/2 to the x minus 3 power. You can pretty much do anything with these. So y is equal to negative 4 times 2x minus 9. But if you notice in like all of these, and I'll do one more just to fill up the screen here, y is equal to 3 to the x minus 7 plus 2. If you notice on all of these, the variable is located up where the exponent would be. So um, the variable x is actually located up in the exponent area for the base 2 here, base of 1/2, and this is actually x minus 3, 2 to the x power, and 3 to the x minus 7. All the other stuff going on is going to change the problem somehow, but they're all still exponential problems. So these are all exponentials. If you notice on the right-hand side, we put on here just a quick review of function notation so that you guys remember what it was. So f of x is just a fancy name for y value. So when they say something like f of x equals 3x minus 1, what they're actually wanting you to do for an f of 5 is plug a 5 into that problem. So f of 5 is equal to 3 times 5 minus 1. So everywhere you see an x in that problem, you can actually kind of plug in the 5. And this becomes f of 5 is equal to 15 take away 1. And 15 minus 1 is 14. So really, what this f of 5 is equal to 14 means is that your x value is 5 and your y value is 14, or the ordered pair 5 comma 14. So this is a review of things that we've talked about. So the review of um, function notation from back in the day. Just a refresher, make sure everybody's on the same page. I don't want anybody to kind of forget this stuff. All of this stuff keeps coming back and keeps circling back. So we just want to make sure that everybody kind of remembers everything. I told you guys before, really everything new that we've kind of learned is kind of past. So everything that we're going to kind of keep learning from here on out is going to take stuff that we've already done and kind of put it together with something else. So for example, now we're going to take this function notation and we're going to try to graph this f of x equals 2 times 5 to the x power. This is definitely an exponential function. So exponential. function, and it's an exponential function because of that x right there in the exponent. And what they want you to do is they actually want you to use this line on your kind of table to fill in with the -1. So if x is -1 and you put it in there, it would actually be 2 times 5 to the -1 power. And if you guys know anything from your homework, this is where your calculator is going to come in handy to actually enter this. So your calculator is going to come in handy when you kind of enter these problems. So if you're entering this in the calculator, I want you to enter 2 times 5 and then an up caret, and then the -1 goes up for the exponent. So the up caret is located on the clear button, like always, and the -1, you just type that in. And your cursor on your calculator will stay up there until you move it to the right. So you got to make sure to know where your cursor's at on your calculator as you're entering these. When you hit enter, 0.4, that is the f of x, or the y value that you're going to get. So you're going to do this for all of them. So you're going to do 2 times 5 to the 0 power. So over here, 2 times 5 up caret 0 power, and hit enter. This is 2. You're going to do 2 times 5 to the first power. This is 10. You're going to fill out that whole table. So 2 times 5 to the first power, 2 times 5 to the second power, 2 times 5 to the third power, 2 times 5 to the fourth power, 2 times 5 to the fifth power. So, and you do have to do all of these. 2 times 5 to the second power. And you're going to notice what's going to end up happening, because exponentials, if you guys remember anything about them, they grow very fast. 2 times 5 to the third power. And you're going to notice these numbers are going to get pretty big pretty quick. So 2 times 5 to the fourth power. And then you're going to do 2 times 5 to the fifth power. So 6,250. And the numbers are going to go so quick that there's going to be a possibility that your tables are going to actually be bigger than your graph paper will allow. I want you guys just to be able to graph the dots that are able to be graphed. So only put the dots on the graph that you can actually do. Don't try to make your graph paper bigger by put like 6250 on the graph paper way out there. Don't try to put anything outside of the range that is kind of given to you on the graph paper on the worksheet. So keep it within kind of reason on your graph paper. If they give you a blank piece of graph paper, you can actually go as much as you want. But if I remember right on your worksheets, most of the graph paper that we give you has kind of already been labeled one way or the other, so that you guys just really need to put the ordered pairs on there. And if you notice on this graph, when you plugged in x -1 here, it actually made the y value a decimal. And the reason why it did that is, you guys keep forgetting about negative exponents that we learned last Monday. So this has a negative exponent. So this negative exponent shouldn't be up top with the 2. It actually should be on the bottom, and the exponent becomes positive. So on your homework and everything, and I'm going to send the answers to the homework home so you guys have them, and make sure that you're double checking all your homework and stuff like that. But this is actually 2/5, and if you think about it, 2/5 is actually 0.4. I will tell you that decimals are easier to graph than fractions, but they do mean the exact same thing. So when you guys see those negative exponents, you might expect kind of a weird number now. So because of negative exponents and what they do to the problem, they actually kind of change it. So the 2 times 5 to the negative 1 is not going to end up being a number that maybe you expect. But hopefully you guys start to learn that the negative exponents are going to change that problem and make it a fraction. So that's why that kind of decimal pops up in the middle of the problem. So there's your table. So you go down to the next one. I believe they want you to actually do a table for this one again, so we can actually use the numbers that we already used. Negative 1's 0.4. 0 was 2. 10. What was the other one? 2 was 50. 3 was 250. And then 4 was 1,250. Now I do want to fill these out just so to be kind of what it wants. So in the case of this one, I'm going to plug in 2 times 5 to the negative 2 power. See what it gets me. 0.08 and 2 times 5 to the negative 3rd power. Let's see what it gets me. 0.016. So the idea is now I've got all these decimals and I've got all these numbers and I actually have to graph them on that piece of graph paper you see over there. So the first one is negative 3. So negative 1, negative 2, negative 3. So you go to the left, 3. And to go 0.016 is to barely get above the kind of x-axis. Because if you notice, the scale goes by 20s over here. So negative 1, negative 2, negative 3. 0.016 is barely going to leave that line. 0.018, still going to barely leave that line. 0.4, barely going to leave that line. Now, 2, you have to remember this is 10, so 2 is still down there. Now, 1 at 10 actually gets to move up. So you have to watch your scales on the axis. And we notice that this one only goes up to 250, so we're probably not even going to be able to graph the 1250 on here. So then the next one is 1 and 10, and then 2 and 50. And this is that shape that we talked about, that kind of roller coaster L-shaped graph that happens. And 3 is all the way up to 250 already. Now, what you guys have to do is you have to be able to draw this. So it's just going to keep kind of flat here, never going to cross 0. And then it's just going to kind of raise up, and it's going to keep going, and I'm probably going to mess up. And keep going, and leave the paper like that. So your graph is that L-shaped graph that starts on the bottom left and then just kind of grows and rockets up. Notice I didn't get to put 1250 on there, but that's not a big deal to me. So the 1250 is not a huge deal to me. The 250 also is the last one I could put on there. You really can't even put these decimals on there, but you put them as close as you can to the x-axis, and kind of I'm okay with that. Just don't cross that line. If you guys remember, that was called the horizontal asymptote, and the horizontal asymptote was that line that they couldn't cross. So we're going to do another one. So we're going to do this other one. This one looks way harder to type in. Okay. So this is still your y equals. This is still your 12 times 1/3 in parentheses. Raise it to the power and then go out and do a minus 10. This is all well and good. Now I'm going to show you a couple things. So on your calculator, you are more than welcome to type all of these in. Let me clear this So you are more than welcome to type that whole thing in every time. So let's do 12 times parentheses 1 divided by 3 raised to the power of -4. Make sure you hit the right arrow key because you don't want to be in that exponent anymore, and then -10. And you are more than welcome to actually put all of that in there like that and hit enter. 962. But if you guys remember anything about your calculator, making a table and graphing is what this calculator is good at. So instead of having to do that every time you want to do one, what I would suggest is you go to you go to y equals, and you type in this equation with the x. So this is your y equals, and then I do 12 times, parentheses, 1 divided by 3, close the parentheses, raise it to the x power, so that x button is next to the alpha button. Get out of there, make sure you get out of that exponent, and then put -10 behind it. I would always double check it to make sure that you're out of there. I know that you guys are just like me. You sit there and you look at the keypad and you're trying to type everything. You're trying to make sure that everything's right as you type it in. 12 times, parentheses, 1 divided by 3, parentheses, up caret x -10. But you forget to hit that right arrow key, and that -10 sometimes ends up there with the x. I would fix it. Just double check it. Now, if you guys remember, you hit second table, and now all of a sudden, instead of having to look at, make this a little bit bigger, instead of having to type in all of those numbers, now you can just look at the table and kind of fill it out. So -4 is at 962, -3 is 314. Let's see if I can bring that back. It's easier to see. -2 is 98. -1 is 26. 0 was 2. 1, -6. 2, -8.667. 3, -9.556. 4, -9.852. And you kind of see what's going to happen. It starts with a very big number down here at -4, and then it's kind of going down, down, down until it gets really close to maybe -10, and then it starts to level off. So if we have to graph that, you go to the left -4, 1, 2, 3, 4, and you go up 962. It's not on here. So then you go to the left -1, 2, 3, -3, and then you go up to 314. If that's 310, 314 is probably like right around in the worst dot ever. So 314 is probably somewhere around in there. And then it's -2 and 98, so maybe just a little bit below 100. And then -1 and 26, that's 30, so we're around there. 0 and 2 is like right there. 1 and -6. Now you have to remember, these little lines are tens. So if that's -10, -6 is probably like right there. And then right there is -8.667, and it's not going to cross -10, but it gets really close. So this line actually starts at the top and goes down through these dots, and then kind of tails off and ends up out there somewhere. No matter what number you're going to plug in, that is never going to cross -10. So if you start to look at this and you want to press the down arrow on your calculator, that number is never going to cross -10. Now your calculator eventually says it hits it, but that's not true because it's rounding. So it's 0.9999999 something, 0.9999 something, but your calculator just kind of gives up and says, yeah, whatever, it's 10. So your calculator is kind of the robot that's lazy. So, uh, but that's how you use your calculator to make you a table to help you with your homework tonight also. So we have to go through some kind of what we call vocabulary for this. So for exponential growth, the graph is going to start at the bottom and kind of go up and leave. So your y values increase as your x values increase. Exponential decay starts at the top, goes down, and kind of levels off. These are those L-shaped graphs, those roller coaster graphs, uphill, downhill. So this one, your y values decrease as your x values increase. So exponential growth is your x values go up as you go to the right. And exponential decay, your x values go, or your y values go down as your x values go to the right. So that's what gives it that shape of kind of that L-shaped graph, and this one gives it that kind of J-shaped graph. So it's one of those things where exponential growth and exponential decay we'll be talking about quite a bit. So knowing which one is which and what the graphs look like is an important thing. And the horizontal asymptote is the imaginary horizontal line the graph cannot cross. So in the case of these two graphs, that imaginary horizontal line is something that like runs directly underneath here, and it runs directly underneath that kind of orange graph. So it's that dotted line that they can't cross. So if you have a graph that kind of goes uphill from left to right, it would be this line that they don't cross. And if you had a graph that went downhill, it would be the same thing. It would be this imaginary dotted line that it is not going to cross. Alright, and the very bottom, every note's, this is just what we're going to call the general form. So the general form of the equation. They're going to add a little number in front of here, but it's a number in front times, or something times a number raised to the x power. What makes it an exponential is the variable. The variable is the exponent. All right, so that is lesson 12.3. Your guys' homework should be the worksheet. It should be the same worksheet as your online bookwork. So You guys can go ahead and get started on that. Take the time in class, make sure you're working.